Okay, here we're going to do a hypothesis test on a proportion. Here we have an example of one of your homework problems. In a program designed to help patients stop smoking, 234 patients were given sustained care, and 80.2% of them were no longer smoking after 1 month. We want to use a 0.10 significance level to test the claim that 80% of people stop smoking when given sustained care. So here our claim is that it's equal to 80%. Okay? So now we want to identify our null and alternative hypothesis. Remember that our null hypothesis is always equal to. So we can eliminate options C immediately. We also know that the alternative is going to be the opposite of our claim. Since our claim is equal to, our alternative is going to be not equal to. So we're going to select D here as our null and alternative hypothesis. And now we want to identify the test statistic for the hypothesis test. We're going to use StatCrunch to make that happen. So I'm going to go to Stat, and I'm going to go to Proportion Stats. I'm going to go to one sample with summary data. We have to put in the number of successes. Now our successes that we got here was 80%. So to calculate that, we can do 0.802 times 234, or we can get StatCrunch to do the calculations for us. So I'm going to type in 0.802 times 234, and then our number of observations is 234. And now we're going to test our hypothesis test. Our null hypothesis is going to be 0.8, and our alternative is going to be not equal to. Don't touch this radio button here, confidence interval. That's if we're doing confidence intervals. And then we're going to go ahead and click compute. And then we're going to get all the information that we need. We have our test statistic, our z-stat, that's going to be here. So we're going to round that to 2 decimal places. That's going to be 0.08. We're going to do the p-value of our test statistic. That's going to be 0.939. And now we're going to come to the conclusion of our hypothesis test. Remember that our p-value is much greater than our alpha. So that means that we're going to fail to reject our null hypothesis. So now we have to come to the wording of our final conclusion. And we can use this chart to help us out. Does the claim contain the condition of equality? Yes, it did. We are saying that it was equal to 80%. Do we reject the null? No, we failed to reject the null because that p-value was greater than their alpha. So there's not sufficient evidence to warrant rejection of the claim. So we're following this track here. We're going here to here, and then we're going down to this second box that's right in here. So we're going to fail to reject the null, and there's not sufficient evidence to reject the claim that 80% of patients stop smoking. So what this means is that we actually accept what the test is trying to tell us. They claim that 80% of patients would stop smoking. We got 80.2%. Because our sample size was 234 patients, we can actually support this claim. Now, we're not actually technically supporting it because it's not exactly 80%. We're looking at an interval of things that we're willing to accept. That's why it's selection D, where we fail to reject the null. There's not sufficient evidence to reject the claim. Well, if it's not sufficient to reject, that means we kind of accept. All right, let's look at a different example here. Oh, this is a good one. An online poll asked, and I'll increase this a little bit here. An online poll asked, do you believe the Loch Ness Monster exists? So out of 20,000 responses that they got 63% said yes. We're going to use a 0.05 significance level to test the claim that most people believe the Loch Ness Monster exists. And how is this conclusion affected by the fact that internet users who saw the question would to decide whether to respond? We'll talk about that in a second here. But first of all, our claim is that it's most people. And that's all we really have to go on here. Well, if it's most people, it's going to be greater than 50%. So that's going to be our claim, is that P is going to be greater than 0.5. So that means our null is going to be equal to, and since our claim is strictly greater than for you guys here, right? So a strict claim is going to be strictly greater than. That means our alternative is going to be the same as our claim. So we're going to select option D. Now we want to identify our test statistic. So we're going to go to StatCrunch. We're going to go to Stat. We're going to go to Proportion Stats, one sample with summary. Our number of successes was 63% out of the 20,715 that we had. So I'm going to do 0.63 times 20175. And our observations were 20175. Now, some of your problems, they'll tell you how many successes that you have. Go ahead and put that number here into your number of successes. Our hypothesis test is 0.5. That's the default. That's actually what we want in this case. But we need to change our alternative hypothesis to greater than. I'm going to hit compute. And we have everything we need. Our test statistic here is going to be 2 decimal places. So that's going to be 36.93. Remember that this is 37 standard deviations above the mean. We're really rare, right? We're in rare territory here. Maybe I didn't round it right. 36.93. Okay, I figured out what I did wrong here. My total I typed in wrong here. I have to edit that to 715. And I'm going to change this to 715. Great. Now I'm going to go ahead and compute that. We're going to come to the same conclusion. It's going to change the value of my test statistic to 37.42. And then my p-value here, it says that it's less than 0.0001. If that's the case, you just put in 0. And now, our p-value is way less than our alpha, so we're going to reject the null. We can go to our chart to figure out what we're going to do. Does the claim contain the condition of equality? No. Remember that it was strictly greater than. Do we reject the null? Yes, we reject the null. So the sample data supports the claim. We're going to be down in this territory right here. So the sample data supports the claim. We reject the null. There's sufficient evidence to support the claim that most people believe that the Loch Ness Monster exists. And this is how you're going to do all of your hypothesis testing problems when it comes to a proportion.